I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll prove a trigonometric identity which is based on double angle formulae. Well, in case you want to learn from me, you can always send an email on the address given. Let me thank all the viewers and subscribers for their excellent feedbacks and beautiful questions. Here is one from one of my students, and I hope its solution will help many others. Well, this is also a question which I have seen many times in a test paper. We need to prove that secant theta minus tangent theta equals to tan of pi by 4 minus theta by 2. Now, as soon as you see this kind of equation, double angle and half angle formulae should come to your mind. Well, if you don't remember them, here is list of related formulae for you. You might need all of them. To begin with, tan, so tan a plus b is equal to what? Well, let me write a plus and minus b here, right? So, tan a plus b or a minus b is tan a plus or minus b plus or minus tan b over 1 minus plus tan a tan b. Tan pi by 4 is 1, and therefore you can see how this formula could get modified to 1 minus tan of theta by 2 over 1 plus tan theta by 2, correct? So once you have tan theta by 2, you might like to know the formula for sine theta by 2 and cos theta by 2, right? So let me write sine a by 2 here. Will be, or rather, let's write the formula for sine 2 theta. So sine 2 theta is 2 sine theta cos theta. You could change theta to theta by 2, then 2 theta will become theta. You get the idea, right? Similarly, cos 2 theta is cos square theta minus sine square theta. This is normally written in 3 ways, right? So also as 2 cos square theta minus 1 or 1 minus 2 sine square theta. So these are your basic formula to work with. Half angle really means you can substitute theta by a by 2, correct? Something like this. Perfect. So let's now begin. To prove this identity, I could start from either side. I could actually start from left side or right hand side. So this time, let me begin from the right hand side, which is tan pi by 4 minus theta by 2. Okay, so which is equal to tan a minus tan b, that means tan pi by 4 minus tan theta by 2 over 1 plus tan a tan b, in this case tan pi by 4 tan theta by 2. Makes sense? So now we know tan pi by 4 is 1, so I'll write this as 1 minus tan theta by 2 over 1 plus tan theta by 2. Now since we have to get into secant, it's good practice to replace tan by sine over cos, right? So we could write this as 1 minus sine theta by 2 over cos theta by 2. Everything over 1 plus sine theta by 2 over cos theta by 2. Perfect. So now, taking cos theta by 2 as common denominator, or you can say multiplying by cos theta by 2, both numerator and denominator, what are you going to get? Well, you get here, let me squeeze it in here itself, cos theta by 2 minus sine theta by 2, correct? Over cos theta by 2 plus sine theta by 2. Get the idea? So we basically multiplied the whole thing by cos theta by 2 in numerator and denominator. So you get this step. Is that clear to you, right? Perfect. So we have something like this. And now, how do I get secant and tangent from here? Looking back, I think cos 2 theta is cos square theta minus sine square theta, right? That should give you a clue. That should give you a clue, and that is, if I kind of rationalize, right? If I multiply by cos theta by 2 minus sine theta by 2, I will get cos 2 theta in the denominator, right? So that is the idea. So let me rewrite this as equal to. So we have cos theta by 2 minus sine theta by 2 over cos theta by 2 plus sine theta by 2. We are going to multiply and divide by the conjugate cos theta by 2 minus sine theta by 2 over cos theta by 2 minus sine theta by 2. Makes sense? So, in the numerator, we'll get the square, right? And in the denominator, we get difference of squares, right? So, when you multiply these two terms, we get a minus b whole square, right? So, expanding a minus b whole square, we get cos square theta by 2 minus 2 sine theta by 2 cos theta by 2, right? Plus cos square theta by 2, correct? Sorry, sine square theta, a minus b, right? Divided by the difference of squares, which is cos square theta by 2 minus sine square theta by 2. You see that? Now the denominator here is cos 2 theta, means twice theta by 2, right? Which will give you cos theta, right? And in the numerator, you have a term which is cos square theta by 2 plus sine square theta by 2, which is just 1, right? So let me rewrite this as 1 minus 2 sine theta by 2 cos theta by 2, right? Over the difference of squares, which could be written as cos of 2 times theta by 2. Make sense? Twice the angle theta by 2. Now in the numerator, 1 minus 2 sine theta cos theta gives you an idea. That is 1 minus. And that is sine 2 of theta by 2, right? So I can write this as sine theta. And in denominator, we have cos theta. Now if I divide 1 with cos theta, I get secant theta, right? Let me rewrite. I just squeezed it in, right? And that is the right hand side, which is secant theta minus tan theta, left hand side. So I'm just writing left hand side here. Does it make sense to you? Correct? So I squeezed in the solution for you. So I hope the steps which I have missed here are clear, right? So basically what we did here was we expanded tan pi by 4 minus theta by 2, getting an expression 1 minus tan theta by 2 over 1 plus tan theta by 2. Wrote it in sine and cosine terms, multiplied by cos theta by 2, both numerator and denominator, getting rid of this denominator, right? And recognizing that rationalizing would help us give cos double angle formula, difference of squares, we did rationalize it. This was a very critical step. And then we got our double angle formula. And therefore the result, perfect. So I hope with this, the steps are absolutely clear. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'll be great. Thanks for your time and all the best.